Thank you. Welcome to this presentation. So the title is Integration in the Cloud Area with Camel Quarkus. And we will try, I will try to share some illustrative tips about what it means to develop with Camel Quarkus. But please first, let me introduce myself. My name is Alexandre Gallice. Actually, I'm working as a senior software engineer at Red Hat. And prior to this, I was already a Camel contributor. Specifically, those days, I'm mostly working on Camel Quarkus, and this is the topic for today. Which brings us to the plan of this presentation. And first, I will try to have a quick reminder because we have a lot of content just to embed everyone in the presentation. Quick reminder about Camel, quick reminder about Quarkus. And then we step into the presentation. And the idea is that we will step into the shoes of a day-to-day Camel Quarkus developer and review some useful tips that moreover show the integration between Camel and Quarkus and how great it is. So last step, it's no more on my local machine. It should happen on a cluster, but actually I have taken some screenshot of this demonstration to go quicker and to avoid some failure on the cluster. But still, the topic is the same. Everything happened on the cluster, and we will review an interesting example involving Knative. So we go very quick about the recap. Camel, it's there to make the communication possible between heterogeneous systems. And here in this slide, we have system A, system B. And when you think about it, you face an integration challenge. What we would like to do, a key capabilities will be to extract some message from a given technology. That's a feature of Camel. And conversely, at the end of the pipe, you would like to produce to another technology. So this ability to consume and produce two technologies, this is core of Camel, but we have more than that. And at the bottom of this slide, you see the root concept. And the root concept, this is what will do, the link, the mix between all the system and where you will write your integration logic. We could briefly review it. So first, this is all the possible deployment options. Today, we will concentrate on Quarkus, actually. Now I come back to a typical Camel route. What you would like to do, you would like to consume from, let's say, 300 plus technologies. This is a number of technologies you can target with Camel. And then most of the time you will face, some kind of integration challenges, but that are not new, actually. They are there since a long time. And the good news is that there are proven integration recipes to answer this. They are called enterprise integration patterns. And the good news is that within Camel, they are accessible with keywords that you can use as is. And the last step of a typical Camel route would be to produce to conversely 300 plus technologies. This is best summed up in the bottom of this slide in the pseudocode of a route. And you see from SQL, so here we are just turning out SQL records into exchanges that will flow in Camel and reach the next step of the pipe, which is the filter. And here with this keyword filter, I use an enterprise integration pattern. And this one, it times you define a predicate telling what's useful, what's not. And there we go, we have a filter, what we don't need. And it makes that at the last step, we will send to another technology. Here it's an Amazon S3 service, and only the messages which are useful will reach these steps. And now let's have a quick recap about Quarkus, and then we will switch to the demo quite quickly. Quarkus, it's a build-time augmentation toolkit, and the main, the main things is fast startup and low memory. This is really a key point. You have more in Quarkus. You have the developer joy with the dev mods that we will see in action, and the possibility to reuse some good old specification like CDI, microprofile, and you will see that there is some interest, especially when mixing Camel and Quarkus. I don't tell too much about the deployment option. You have the GMVM mode and native mode, but we will review that at the end of the demonstration. So I think right now it's time to switch to this schema, which shows the typical framework startup. And you see in blue, you have what happened at build time, and in red, what happened at runtime. And the typical framework we will do less at build time and most at runtime. And Quarkus will do the opposite. Quarkus will try to load configuration files, scan the class path for annotations, build its own view of the world at build time, and then do at runtime only what's necessary. I think right now we will move to the demonstration. So here, we would like to step into the shoes of a day-to-day Camel Quarkus developer, and then we write a route where we will have our integration logic. So we extend here the route builder, but here this is an endpoint route builder. I will explain this a bit more. The key point when you write a route is that in the configure method, you will be able to use some DSLs. And Camel offers the REST DSL. So here we define just an endpoint, a REST endpoint, which is listening for incoming GET requests and slash steps, and then forward it to direct steps. So now we need some things which is listening on direct step. And this is what happened here is another part with another DSL, the Camel core DSL, where we read from direct steps. So here we have just bridged for the exchange incoming by the REST endpoint, and we bind it to the Camel logic. So here we will be able to use, our keywords to have integration patterns and also produce to target technologies. Well, so I would say at this stage, we have like a prototype ready to run, and we will see, it running. So there we go. In this window, we will enter the dev mode with Maven Quarkus dev. The key point is that it will, build the application, launch it, and after a few seconds, and actually a bit more than 3 seconds, we will see why later on, we will be able in the middle shell to launch this HTTP localhost command, and you see that effectively we will have an answer which is hard-coded after a few seconds. The application is started, and after a few seconds, we have the answer hard-coded step 1. The goodness of the dev mode now is that when I will modify the route, so for instance, I modify here by trying to invoke some custom Java code. I do this with the bin component in Camel, and I try to locate a step to bin, the bin name step to bin, which should be there in the registry. And the good news, in Camel Quarkus, the Camel registry and the Quarkus registry are both merged. So when you think about it, using this @name annotation, standard CDI annotation, I can define that I have the bin. So Camel is able to locate the bin there and try to bind the exchange to the step method, which is the only method available in this class. And I will just, like suffix the content with -step2. So really simple. But yeah, before seeing this in action, I would like to remember 2 key points. Here we have a static initializer. This one is, simulating a long configuration task that will take 3 seconds to run. And this is important. We will come back to that later. Another key point is we have this @register for reflection annotation. And okay, just remember that we will come back at the end of the demonstration. So back to our prototype evaluation. And here what happened is that under the hood, Camel Quarkus in dev mode automatically restarts the application with the developments added. And then I have my step 2, which is there. So, it's like you have a constant feedback loop about your development. We are able to invoke some custom Java code via a bin. Well, okay, that's great. You know what? I will switch to, I skip a point because I'm short on time. We will directly go to another steps where, as a day-to-day Camel Quarkus developer, you would like at a given moment to produce some logs. And here we go. With Camel, we have this opportunity to use the logs component and define a test category. Right now, if I use my application, I see that I have effectively a test category log, which is there, but it's like a bit, let's say there are too much information, and we would like to filter a bit this. So in a way, we would like to tune the log component, and there is a way to do this with Camel using an observer method. So this is a CDI pattern implemented by ARC on Quarkus. And the idea is that we will intercept the addition of the component event, of the component add event into the Camel Quarkus context. And there we will be able to tune a bit the formatting. This is what I am doing here. So proof, if we go there, the application has restarted. Also notice that each time the application is started, you have this 3 seconds delay, which is there. The static initializer, it executed in dev mode at each startup. Well, if I run my application now, I have some clearer log, which shows I have been able to tune my component by means of Java code. Well, that's interesting to know. Okay, if we go through back to our route, conversely, the last step we would like to do when you are writing a typical Camel route, we would like to produce your messages to target technologies. Here, we have chosen to target the NATS technology. So we will produce to a NATS topic. And yeah, there is something interesting here. We have some options. SSL context parameters. Yeah. So we pass a bin to the endpoint creation, and then this bin is injected from CDI. You know, still how we could match mix CDI and Camel, Quarkus and Camel. And so we are producing an SSL context parameter. So this one is defined with another pattern, simply a producer method, you know. And as the method is named SSL, you know you know what happens. Then we will have a bin of type SSL context parameter in the registry, which is named SSL. Okay, that's pretty simple. I just want here another things to remember. Please keep in mind we have some resources, keystore.jks, truststore.jks, and at the left you see that they are stored as resources, so deployed in the jar. So please just keep this in mind, and you will see that, yeah, we may have surprise with this later on. Okay, so right now, I think I should have, oh no, my application is not running. What's happening? The servers must be specified. What does it mean? We take a few steps back. Here, we have a NAT server in the bottom shell, which is listening on port 4222, okay? But we have never told to Camel where to find this. I mean, the NATS component don't know about this URL. So if you follow me, we would like in a way to tune the NATS component in order to target this specific URL. So one way to do this is by writing Java code as we have done previously. But here there is another way by the means of properties with a convention. And the convention is Camel components, NATS servers. So here I tune the server URL of the NATS component. And just with this, after a few seconds, the application is restarted. We have the 3 seconds sleep for the static initializer. And I launch my requests. I have my log, but this time I have a message payload, which is logged inside the NATS server. So we have our loop, everything, the communication with NATS happens over SSL, and everything is fine. Okay, now I think, okay, you know what? I will just show you some things because I have a few minutes left. You know, we have the possibility to use a Camel bin, a bin. And here, the good news is that we are able to substitute the bin with the help of Mockito and Quarkus. So we write a Quarkus test this way. So Quarkus test is an annotation from Quarkus, just JUnit 5 extension. And inject mock is a goodness which, you know, make us able to overwrite the steps to bin with some Mockito statement like this. When the steps to bin is called, then we will return step 1 mocked, and not step 1, step 2, or step 1, depending, you know, on the moment of the demonstration we were at. So with rest assured, we are able to do in the situation where we have slash steps, incoming requests and slash step, we expect the status code of 200 to be returned and the body to be step 1 mocked. Let's check whether it's working. We run this as a JUnit test. And after a few seconds, we will have, you know, the 3 seconds in order to have the application starting. Okay. And after that, the context starts. And on the left, we see that our test is running. And after a few moments, the test is ready, is green, which means that we have been able to substitute our bin via a mock. Okay. I think we have reached a situation where our prototype is, you know, somehow quite well, and we would like to pass to the deployment option. And here there is something. I will go very quickly about this because we would like to build it in the native mode. Okay, the JVM mode, you know, is just a bit standard. So we will do some things like Maven clean package -d native. This command, honestly, it will take some things like 3 minutes, maybe more, as we are in a demo with some things running on my machine. So you know what? I have prepared everything. We have here some pre-compiled executables, and I will run the first build one. And what happens? Damn, we have an issue. You know what? The search keystart.jks file. Simply, we have an issue because it's not there inside the native executable. This is like tricky issue with the native mode. So just to show you, the answer is that we need to use this Quarkus native resources includes, because we need to manually explicitly set that those resources are to be embedded inside the native executable. And after we do this, we recompile. It's another 3 minutes. Good that I have said sometimes. The build is already performed prior to the demo. This time I run it, and well, I have my localhost, my HTTP request, which is launching. I have my log, which is there. Plus, I have my message payload, which is logged inside the NAT server and which communicated over SSL with with everything embedded inside the native executable. There is one more thing I would like to show you, and then after I will explain a bit more the native mode, in the sense that, yeah, you see here, we don't sleep 3 seconds for the startup. I will try to see the startup time, 500 milliseconds. In JVM mode, it was some things like 3 seconds plus 3.5 seconds. And here we save 3 seconds each time, because in native mode, the static initializer is best executed at build time on send-forward. 22 minutes, I will go very quickly about this part. This is a table which is just showing the differences between the JVM mode and native mode. I will go very quickly. In JVM mode, we are producing a fast jar, a jar which is optimized by Quarkus in order to start quickly and use less memory. That's really, compared to a typical Java framework, that's really a fair option. In native mode, this is going another dimension, in the sense that the build is quite slow. The debugging is hard, but the boot time and memory usage, they are so better. But it doesn't mean that it's applied to all situations. And actually, the use, if we speak about use case in JVM mode, it's more for a simple long-running service, and in native mode, some short-running services which are distributed over multiple Kubernetes nodes, starting, more oftenly and that thing. Yeah, okay. I just go quickly about the recipe. You know what? I think I will switch directly to the but yeah, just to summarize. There is, when building a native executable, most of things are happening at build time with a recipe which is there. And it is bringing us extra responsibility as a Camel Quarkus developer. Sometimes things that could be discovered in JVM mode could not be discovered. So this is why we have this at register for reflection annotation in the bin, just to let Camel Quarkus knows that this bin could be invoked by reflection. If you don't do this in native mode, it will not work. Okay, so some extra responsibilities. Well, now I would like to show you a few screenshots, and here we have, a bit the same kind of applications. So an hello world applications, I compile them in native mode and deploy them as knative services. And this is the first screenshot we are seeing right now. We have 4 knative services deployed, and they could be reached via 4 distinct URL, which make us go to the second window. And here you see in the bottom shell that we have the list of pods which are currently running, and we have 0 pods running. It's totally normal. It's because Knative has the possibility to scale down to 0 when nothing is used. And this is a context which could be interesting. So first, if we try to, with the hello JVM command in the upper shell, we trigger some HTTP traffic, and then what's happening? We have on the fly the creation of a Kubernetes deployment. Knative detects some input traffics and asks Kubernetes to create a deployment on the fly. After moment, the deployment is ready, and we have our first request saved here in 6 seconds. So what really matters in this kind of environment is the time to serve the first request. 6 seconds here in JVM mode. Now let's review the situation. If we switch to native mode, no, first subsequent request is they will not take 100 milliseconds. They are served more quickly. Here it's 100 milliseconds, for instance. You know, what's important is really the time to serve the first request. Now, if we switch to native mode, you can see that we are down to 2.6 milliseconds. It's somehow, you know, 3 seconds which are saved, and you get it. This is the 3 seconds from the static initializer. Subsequent requested will run much quicker, 70 milliseconds for each. So yeah, we have a bit the same behaviors than in JVM mode. Okay, now this is about the boot time effect. Now I would like to show you another thing. It is about the memory effect around the native mode. And for this, in the bottom shell, we see now we have this memory quota. For people who don't know Kubernetes, this is just, you know, a way to say you will have let's say a limited amount of memory. Here it's 500 megabytes of memory. We sum up in a namespace the memory request is for all the containers inside the namespace. And if we go above this limit, then actually it's not possible. And we will see the consequences here in our small demonstration. Let's go. If we run hello JVM, deployment occur on the fly, and we will have our first request served in 6 seconds. Yes, but we see that we are already using 300 megabytes of memory for that. Okay. Now, could you guess what happened if I run hello by JVM? By JVM is just the same service saying bye, but it's also using 300 megabytes of memory. So there is something like 300 plus 300, it's beyond the hard limit. So what will happen actually? Let's just try it. And we see that actually nothing is happening. It's perfectly normal. Knative detects some incoming traffics, asks Kubernetes to deploy on the fly, but Kubernetes said, no, this is not possible because it will break my hard limit constraints. So it waits. It's waiting. It's waiting that the first deployment, the hello JVM deployment, will tear down, and this is happening right now. After, when the deployment has teared down, by JVM will be able to trigger another deployment, and the time flies by. And after 47 seconds, we have our first request served. And you know, this is really key points. You see in this constraint, with this constraint environment memory, how actually memory could also translate into latency for the first request, you know. So at the end, if we review the situation in native mode, we can call hello native. This is 100 more of memory, but it's still, you know, can be contained in the 500 megabytes, and we can still run by native also. So in this context, it's like we could run 5 applications in native mode for only a single in JVM mode. This is extreme example, but I hope you feel the things. Okay, I think we are reaching the end of the demonstration, so better switch to a conclusion. Really, I hope that you have a better idea of how to run Camel Quarkus. And if we sum up, we have seen what? We have seen that we have the possibility to consume and produce some messages. We have the possibility to use some EIPs. And there are more goodness in Camel Quarkus, but yeah, we focus on that already. We have the possibility to use bin binding, you know, a way to invoke some custom Java code in order to process the exchanges. We can mock the bin that we have created. We can tune some components to influence the way, to configure the way Camel Quarkus is working. We can tune components by code. We can tune components by configuration properties. The native mode, I did not have as much time as I would like to expand, but you see that there is some interest. It could be awesome in some situations, but not all situations. And with this environment, with Knative and demand with memory constraint, I hope it is, you know, like a good illustrative example of where the native mode could shine. If you would like to retain just few words, it's all about lightweight pattern-based integration running in the cloud. I think we should have time for few questions. Okay, no, I still have 5 minutes for the presentation. Okay, so perfect. I will have the time to go back here to the native mode. 5 minutes to go dive in the native mode. So the recipe, the native mode is based on Graal substrate VM. The idea is that it's just another kind of VM, you know, but taking another assumption, a closed world assumption. What it means? It means that everything is known at build time. And if this is not true, no worry. You still think that this is possible. What it makes possible? It makes possible that if you know everything at build time, you can prefer to boot your application at build time. And we have seen this with the static initializer tree. Also, if you can prefer to boot your application at build time, that after that, you can take a snapshot of your application startup memory. And bit for bits, you store this inside the native executable. So that's the first part. But there is another interesting property if you think you live in a world which is closed. You can, you know, at build time, traverse the code which is strictly needed in order to run because you know everything at build time. And so you select what's needed, you know, dropping all parts of the JDKs you are not using, I don't know, dropping third-party libraries you are not using, or even your own, I don't know, your methods and your fields that you are not using inside your code, you know. And you embed this inside the native executable. And so now when you think about it, in order to start, what's going on? You just take the snapshot of the application startup memory. Bit for bit, you store this inside the memory. You know, that's quite quick as an action. And second step, you run the code which is strictly needed. And this is really the recipe for instant boot, tiny memory usage, and low disk. As we have seen, the native mode also comes with some complexities. You need to know more things. So we have seen these resources include just because actually we are, you know, using including those resources from Java code. You know, you remember the configuration of the SSL context parameter. Here, this is some, you know, statements, and from the statement, we would need to deduce that these resources will be needed at build time. Actually, this capability is not implemented in Camel Quarkus, native image, and everything. So this is one extra responsibility for the developer. Another one, which I could explain a bit more, is this at register for reflection here, where you have, yes, because, you know, Camel can detect the bin by the name, but then it needs to select a method. Here, there is a single method. So it invokes it, but it does it by reflection. And reflection is a dynamic feature which assumes that some things will evolve at runtime. And here, we live in a world where everything is known at build time. So we break the assumption. And this at register for reflection annotation, what it will do, it will let native image, the Graal VM tools that build, you know, the executable, it will make native image knows that this class should be integrated inside the static analysis. So it's like adding one more pass to explore during the static analysis and see what's reachable or not. Well, with this, we have our two examples around the native mode. One more thing, because we have been very quick about this table. Okay, just 1 minute more. I would like to share a bit about performance, because in the JVM mode, the performance is based on runtime optimization. And I want to stress the point that you have the JIT compiler, which is there. You know, depending on the execution profile, it will make some hot pass, some code pass hot and execute them faster. So you are like dynamically tuning against the current usage. In native mode, you don't have this. Everything is known at build time. You don't have this, so you save the cost of the JIT compiler infrastructure. This is one of the reasons for using less memory. But then you don't have the ability to let's say adapt to the code which are running. So the performance profile is really not the same, and it's important to understand that a native application will start quicker, but honestly, on the long run, sometimes a JVM mode application, a JVM application will be quicker, and sometimes a native mode application will be quicker. This really depends. I think we're reaching the top of the 35 minutes. So from there, do we have some question? Alors, I have a question. What are typical scenarios where Camel is used in applications? Really, I go back to the beginning of the demonstration. This is that. You have two systems to make communicate, and Camel is best when you have actually a lot of technologies to consider. For instance, you can one day write an integration route to make I don't know system a SQL server communicate, and the target server is I don't know an HTTP server, and the next day the customer changes its mind, and then you switch from an HTTP server to a JMS server. Here you see that there is something you don't want to rewrite the whole logic. You don't want to rewrite each time the way to access the target technologies. This is one of the typical scenario where you will see Camel. Camel has also a lot of capabilities around transforming between data formats. JSON in input, XML in output, that kind of things, you have some goodness, and you don't want to rewrite every time the client is changing. What are typical scenarios where Camel is used in application? Yeah, and what makes Quarkus especially fits to it? So there are situations, especially when you are writing what we call a pattern facade. It means that, for instance, you have a complex system with all technologies. Camel has a lot of possibilities to target those all technologies. And a lot of components. So meaning that you have a situation where you are able to use some Camel components, some EIPs to target some old technologies, and then you would like to wrap this inside inside the microservices that will be accessible through an API, and then you have all your new system, which is stored in good APIs and microservices way, and then you are able to bridge that way, the old with the new, every different kind of systems. Okay, and so if I go back to the typical scenarios where Camel is used in an application, it's whenever you would have face typical integration patterns problems which are already implemented. So for instance, you would like to consume messages, but you have some pollution. You want to let's say skip some of them. This is the filter IP. You want to aggregate some exchanges. For instance, each messages which is entering having an header which is an importance of 1. I would like to aggregate those by group of 3 and something another property. That kind of things. You have an enterprise integration pattern to do it. So actually, the problem is that there are 70 approximately integration pattern. So the idea is that Camel will best fit when you are able to use those integration pattern when you want to use that. So if there are no more questions, I would like to share with you another question which comes from another conference. In the way, because this is something like we have a feature in Camel. It's already there, and in conferences, people keep asking, "Oh, we need this feature. We need this feature." So here I take a few minutes in order to share with you the endpoint DSL. So if you remember here, we have a two-part DSL routes with the REST communicating with the Camel. And here we send two direct steps. Direct, it's a component which just means pass to the next route inside the Camel inside the same memory. And we have direct steps here, so it's written in with a string, and we can make some typos. And we will discover this at runtime only. While here we have another way, and this is because we are extending the endpoint route builder. We have another way to, and I need to go very quick. We have, these direct steps written as a method. It's really the same thing as the string, but you have a goodness. If you make a typo, you detect this at compilation time. So this is true for the component. This is true for options. For instance, here, this option expect an SSL context parameter. If I put an integer, it's not working. Okay. So the endpoint DSL, you activate it by using endpoint route builder, and you have the possibility. It will help you to detect most, Camel typos and that kind of issues at compilation time. Okay, just 10 minutes. So Really, thank you to participating in there. If you have more questions, I will try to connect to the Wova app quickly. And so, bye. See you.